Hello and welcome to this presentation by Supergroup 2. Last time you heard from us, our three separate movie companies had merged, and we showed you the process we undertook to integrate our databases. Since then, our movie conglomerate, Awesome Unnamed Star Corporation, has been focused on achieving data quality to create insightful business analytics that we can use to make important strategic and operational decisions. In this presentation, we will briefly revisit our mediated schema, describe the data sources we use to fill the databases of the mediated schema, show you the web interface we created so our employees could load and navigate through our data, and finally, run you through some insightful data visualizations we created with Google Fusion Tables. As you may remember, our mediated schema was created from matching and mapping two cinema operator databases and one movie rental database. In this process, we managed to retain all relevant information each company had stored. Our resulting mediated schema is represented by this ER diagram. To fill the databases of the mediated schema, we used two sources. First, we took advantage of the MovieDB's API. This API allowed us access to movie titles and their assigned genres, directors, and actors, all relevant object types in our new integrated database. For all other tables in our databases, we created custom data generators. These generators allowed us to fill our databases with customer information, presentation hall details, and movie language information, for example. To create these, we used the Ruby on Rails programming language. Here is the code for the customer data generator. In summary, the code takes customer first names and last names, street addresses, and email addresses, and randomly combines this information to get as many unique customers as possible. For example, if you input 10 first names and 10 last names, the generator can return up to 100 unique customers using combinations of these names. To make our data accessible to our many employees, we created an intuitive web interface. I'll now take you through the functionality of this web interface, specifically the data loading process, how to navigate through contents of the database, and the analytics we created. Here is our homepage. To load data into our database, we click on the administration link. First, we are interested in loading data from the MovieDB API, so we click on Import from the MovieDB. Here, you can enter the number of movie genres you want to import, the number of movies you want imported for each genre, the number of actors from each movie, and the number of directors from each movie. Each import is randomized. For example, if you would like to import 3 genres, the generator will choose 3 genres at random for you. To execute the import, we click on Start Import. As an example of one of the data generators we created, let's check out the Customers generator. Here, we can specify the number of customers to be created, their first names, last names, street addresses, and email addresses. Remember that our generator randomly combines this information to create as many unique customers as possible. So given we wish to create 100 customers, we need only enter 10 first names and 10 last names. So let's assume we have imported all the data we require. So we can now select Database Content. Let's have a look at the Movies table we just imported into. You can see the web interface displays our movies and some other useful attributes that were imported from the API. And as for our Customers table, again, you see the results of our import, this time from the custom generator, cleanly displayed in the browser window. For some of our tables, we embedded some useful analytics. For example, if we click on Marius Aronson, we can see all the movies he has watched in our cinemas. And then if we click on the Analytics tab, we see a visual representation of related information, such as his favorite genres, which we obtain by examining his cinema and rental history. We have also included more encompassing analytics. For example, if we head to Customer Analytics, we can examine details such as our most profitable customers. And if we navigate to Movie Analytics, we can see information such as sales per weekday to understand which weekday on average is more popular. While the analytics in our web interface provides valuable information to our employees, we thought we would trial Google Fusion Tables as well. We were particularly interested in leveraging their Google Maps functionality with geographical data visualizations, but we also wanted to test how we would create a standard bar chart too. For our first Google Fusion Tables visualization, we wanted to display how many tickets we have sold per state. Of course, we already have this information in our internal databases. A simple query, as displayed here, extracts the relevant data, which we then export as a .csv file and import into Google Fusion Tables. The result of the import can be seen here. Same data, but now in the Google Fusion Tables interface. To visually display this information on a map, we needed to obtain geodata. We found the relevant geodata available in a public Google Fusion table that contained all the location borders for states in the USA. Here is the visualization of that geodata. As you can see, all USA states are highlighted in red. To combine that data with ours, we performed a merge, the results of which are again displayed. This allows us to visualize our sales per state information like so, with the darker colors representing higher sales. A valuable insight we obtained from this visualization is that it is clear most of our sales come from the west coast of the country. California, for example, has sold a total of 738 cinema tickets. We can also examine our turnover per state, which gives us a similar visualization. Probably because our ticket prices do not differentiate much between states, meaning states that sell the most tickets will likely also produce the most revenue or turnover. We were also curious to know of all the actors we stored in our database, which had been nominated for the most Academy Awards for Best Actor. To figure this one out, we performed another visualization with Google Fusion Tables. We first imported the actor ID and names of the actors in our database to Google Fusion Tables. We knew Wikipedia contained all the relevant Academy Award information, and we found that doing a search of Google Fusion Tables for Academy Award for Best Actor gave us this information in a usable format. We then merged this data with our actors table to produce the following table. And then we created an aggregated summary of the table that performed a count of how many times each actor was nominated to create this table. And our resulting bar chart looks like this. Notice Paul Newman and Peter O'Toole are equal first, with a total of 8 nominations each. For our last visualization with Google Fusion Tables, we were also curious to find out where the directors of our movies were born, and of those directors, who has won at least one Academy Award for Best Director. To do this, we again found public information in Google Fusion Tables, which contained a list of Academy Award-winning directors. Similar as before, we imported the directors of our movies from our database to Google Fusion Tables and merged the table with Academy Award results. Our resulting visualization shows the birthplaces of our directors on a world map, with the larger markers denoting directors who have won an Academy Award for Best Director. And that concludes our presentation. Thank you for watching, and we hope you learnt something about our process to create insightful business analytics for our movie company.